Hello, welcome back everyone. My name is Inus Arabi Isa Odmas. Welcome to Khaliltronics tutorial. Here in this video, we are going to solve some problems under stress-strain diagram from where we stop, as we have explained the types of stresses, the stress-strain diagram, and rest. So in this problem, we're going to use the Hooke's law and the other relationship under stress-strain diagram to solve a lot of problems. So without more ado, this is a question that the first question we're going to solve. A 3,340 Newton ball is supported vertically by a 1.9 centimeter diameter steel cable. Assuming the cable has a length of 10.3 meter, determine the stress and the strain in the cable. So before we go and solve this question, we need to have some insight about some statement in the question. First, about the cable. The cable is usually cylindrical in form, so we're going to consider the cable as a cylinder. And then the second, the cable is supported vertically by a ball which has 3,340 Newton. That means the tension in the cable is going to be the force that will act on the cable. So, and the last things to recap is about the area, whereby the area should be the top area, because as the cable is supported by the ball, the force will only affect the top area, that's the normal area. So this is all what we consider in this problem. Then we go and solve the question. So let us start. So we have some parameters given, but let us consider this, for instance, as the cable. So if here is our cable, so now this should be the tension, that's the force, which is 3,340 Newton, and then the length of the cable is 10.3 meter, and finally the diameter. The diameter is 1.9 centimeter. So those are the parameters given. So we use the parameters to find the unknown as said in the question. So now let us find the area, that's the top area or the normal area. So the area is going to be the circular area, which should be the area of the cycle, which is pi d square over 4, and this is equal to pi into 1.9. It is in centimeters, so we need to convert it to meter. So by multiplying pi to the power of -2 all in square. So if you do correctly, you get over 4. So it's going to be 2.84 exponential -4 meter square. This is the area. So now we can apply this to get the stress. That the stress is force over normal area, and we already know our force, which is 3,340 Newton all over the normal area, which is 2.84 exponential -2. So this is equal to 11.76 exponential 6 Newton per meter square. So we can represent the stress in terms of the megaFA, which should be 11.76. That is the power of 6 means mega, and 1 Newton per meter square the same as Pascal. So we have 11.6 megaFA. So that's about this. Now to get this the strength, actually for us to get the strength we need to have other parameters. For instance, we need to consider two expressions that we can use to find the stress. First, let us consider this and see whether we can get the strain from this expression. So strain is equal to extension over the original length. In this question we have the original length but the extension is not given. That means we cannot use this formula directly to get the strain unless we know the extension, that the change in length. So in this case the change in length is not given, therefore we cannot use this formula. Okay, so now let us consider the Hooke's law to see whether we can get the strength. So from Hooke's law said that the stress is proportional to strain, and under this a constant of shear modular, a constant of Young's modular, then this is going to be equal to the shear modular then times the strain. So this implies that the strain is equal to the stress all over the Young's modular. So in this question also the Young's modular is not given, but remember the Young's modular is always constant, and usually it is given in the question to take it as a constant. Even if it's not given and you know the types of material, you can use the properties, the table of the properties of material to determine the shear stress, to determine the Young's modular. So as we know the material is steel, so the information is enough for us to get it is Young's modular, that is from the table. The Young's modular of the steel is equal to 210 gigaFA. This is a constant shear modular, this is a constant Young's modular of the steel. So now as we know this, then we can just apply it to get the strain. That is, strain is equal to the stress over the Young's modular of the steel. As we know the material is steel, and this is equal to 11.76 exponential 6 in Pascal all over 210 exponential 10 to the power of 9 in Pascal by converting it from giga to normal Pascal. So this is equal to 5.6 exponential 10 to the power of -5. So this is the strength in the cable. So alternatively we can use the other expression of the Hooke's law to determine the strain, especially when we were not asked to determine the strain to the stress. That is Young's modular is equal to FL all over AE, where E is the extension. So from this we can use the relationship to determine the extension directly. After that, then we're gonna use the expression that is shear strain is equal to the extension over the original length. So you can use this to get the strain. So that is all about this problem of today, and we will be coming with so many problems to solve with you. And don't forget, if you have any problems with this tutorial and other tutorial in our channel, do not hesitate to forward the question to us. And don't forget to subscribe if you do not subscribe, for you to get any update we bring in the channel. So here we stop. Thank you very much for bearing us. See you later.